Degrees and radians can both be used to measure the size of angles, and it just so happens that we can easily convert between the two measurements when we wish to. And when it's the case of degrees to radians, we can convert by using this sum here, where we have our angle in degrees, and we do the angle over 180 multiplied by pi. So for 30 degrees, we have 30 over 180 multiplied by pi. Now 30 over 180 can be simplified as a fraction to 1 over 6, and 1 over 6 multiplied by pi is just pi over 6. So 30 degrees is pi over 6 radians. And for the same approach with 240 degrees, if we have an angle that size, we wish to convert it to size in radians. Again, we look to see if this fraction can be simplified further, and it turns out it can. We can simplify to 4 over 3 multiplied by pi, and that gives us 4 pi over 3 radians. Now we can look at our last example involving converting degrees to radians, where we have 84. Now we start out the same way, 84 over 180 multiplied by pi. Now, the fraction 84 over 180 does simplify further, but not quite as nicely and as neat as the fractions we have for A and B examples. So sometimes when this happens, what we can look to do is carry out the full calculation. So if 84 multiplied by pi on top all over 180, and to do decimal places, this gives us a value of 1.47 radians. So an angle the size of 84 degrees is roughly 1.47 radians in size. Now, converting from radians to degrees, we again have a standard sum that we can use, depending on what form the radians angle is given to us in. So we can start out with example A. We have 2 pi over 3. If we look over, we multiply this by 180 degrees over pi. Now, the pi's will cancel, one on the top, one on the bottom. What we're left with is 2 times 180 on top. So it's 360 degrees over 3. And this works out nicely to 120 degrees. So an angle the size of 2 pi over 3 radians is of size 120 in degrees. And the same approach with pi over 4 radians. Pi over 4, again multiplied by 180 degrees over pi. We'll have a cancellation again of pi. This leaves us with 180 degrees over 4, which gives us a result of 45 degrees. So pi over 4 radians is the same size as 45 degrees. Now, for example C, the radians are given numerically as 2.6 radians. So we can do the same basic sum. We have 2.6 multiplied by 180 degrees over pi. And this gives 2.6 multiplied by 180 degrees on top, all over pi. And this gives us 468 degrees over pi. And when we carry this out as a division, we get to 2 decimal places a value of 148.97 degrees. So using the lower sum in our box here, we've seen that 2.6 radians we've converted to roughly 148.97 degrees.